what we call it in the ABC reference frame. The frames that the machine can understand. The physical frame. The A, the B, the C. And in the end of the day, we stated that if I need to mathematically model any machine, I need to find the electrical part of the machine, the mathematical model that can describe the electrical part, and the mechanical part, which is the swing equation. And I need to find a link in between, which is the electromechanical torque. And we found a relation between the field energy and the core energy in order to, let's say, to find a torque expression, correct? This is what we did, yeah? So simply, we stated that in the end of the day, we can write TE, which equal P over 2 IABCS transpose partial LSR dash by partial theta R, the IABCR dash, correct? Yep, this is the electromechanical torque. And for the mechanical part, we know that it can be described by the swing equation, which is J d omega by dt plus b omega r, let's say here, m will equal the summation of the torque, which is the Te minus Ti. Yep. And we know the voltage equation, which was VABCS equal to certain matrix IABCS plus d by dt of lambda ABCS, correct? And VABCR dash for the rotor equal RR dash IABCR dash plus d by dt of lambda ABCR dash, correct? And we found a relation for the flux linkage, lambda ABCS, lambda ABCR dash. For linear magnetic circuit, we said that this is LSR dash. This will be the LSR dash transpose, and this will be the LR dash. And here I'm having the current, which is the IAB. Let's take space. So this will be the IABCS, the IABCR dash, correct? So this is the complete mathematical.
دكتور أول واحدة بس. كيف جبناها؟ ما كملناها.
This one? Simply we stated that if I need to find the torque, I need to do either minus partial omega f by partial theta, or I need to do the partial omega c by partial theta. And we stated for linear magnetic circuit,
omega c equal omega.
you can ask Dr. Nihal. He will say that omega f will equal to omega c. Now this one we said it's the field energy. It has a physical meaning. The second one is the complementary space. Has no physical meaning, but it has very, very fruitful information regarding that I can use it to calculate the torque. Why? Because in general, most of the expression is expressed in terms of the current, not in terms of the flux. If I need to use the first one, here I must say lambda is constant, and this one I is constant. And last time we discussed, lambda is constant, the current is constant, is not a physical requirement. It's a mathematical requirement in order to do the chain rule, differentiation by chain. Good. So, if we return back to the first question, why we need a mathematical model?
حكينا دكتور.
أحمد أجيت اليوم صح؟ أخذت علامة؟ So, to keep the 1 point, why we need a mathematical mathematical model, Ahmed said that we have the physical motor. We have the motor itself. If I'm having the motor itself, why I need a mathematical model? I have it. I can't touch it.
protect the motor تست يعني بدل ما انا اعمل تست على الموتور يجي mathematical model بجرب عليه.
So
دكتور مش to understand how it works وعشان تكون خطواته يعني او يعني كل اشياء predictable انه انا عارف لو غيرت كذا ممكن يطلع مع الاوتبوت كذا.
So the two answers are correct.
And how to control يعني أنا كيف نتحكم
Yeah. All the answers are correct. In the end of the day, although I'm having physical structure of the machine, I'm having the machine itself, but in order to understand the operation of the machine, I need to represent it as a mathematical model. Second thing, to control it or to, let's say, to do the stage of the design, in the end of the day, I need to design a controller. And I need to verify the controller. So verifying the controller directly to the physical system will put the physical system and yourself on risk. Why? Because maybe the system become unstable. Yeah? So the first thing you should what? You should guarantee the performance. On simulation, after that, you will take the parameters, go to the lab, implement it. You will need later on to do tuning. Why? Because there's a mismatch between the mathematical model and the physical system. One of the main, let's say, mismatch is what? Is the approximation. Approximation. We are doing approximation, by the way. We are assuming linear system. Linear magnetic circuit, not linear system. Huh? It's a linear magnetic circuit, although it's not. Yeah. We are neglecting, for example, the column of friction, for example. We are neglecting, for example, the dependency of the resistance on temperature. You know that if there's a current flowing in a conductor, it will generate heat, I square up.
Yes.
So in the end of the day, this resistance will change slightly huh? due to the aging. Simply, we are saying that we are going to the nameplate. Yeah, Suleiman. Suleiman, yeah. We are going to the nameplate, and we are taking the information from the nameplate. Yeah, but maybe this machine was manufactured, let's say,
long time ago.
yeah, 20 years ago. Yeah. So the performance are not the same. Yeah? So there's aging effect also. So don't think that if you can do it on simulation, you can do it on practice. There's a mismatch. Yeah? But at least you have clue. At least you have the first step in order to design. Yeah? Good. So let's see now. The second requirement of any mathematical model is to be simple and accurate enough to capture the main feature of the physical system. I don't need to use 1 trillion equation in order to represent a mathematical model in the physical system. In the end of the day, it will be useless. Why? I cannot understand. Yeah? It will need huge memory requirement to code it, for example. Huh? So I need my model to be simple yet accurate, to capture the main feature of what? Of the physical system. The main feature. I don't need to, let's say, to capture something that I'm neglecting. I need only what? The main feature. So simple yet enough to capture the main feature. واحد زائد واحد قديش؟ Genius. So now let's see. Here, if I expand the torque, it will be around 20 to 30 terms. Yeah? So it will be complicated to understand what I should modify in order to control the torque. If I need to control the machine, I need to control the torque. If you remember, if you recall, any drive system must contain a current control or inner loop or torque control. Yeah? So I need to manipulate the current to regulate what? The torque. But simply here, how I can do that? It will be difficult. Yeah? If you recall, the DC machines was very simple.
Yes.
The relation is very simple. The torque proportion with the flux and the armature current. So I can manipulate the armature current by manipulating the voltage, so I can control the torque, so I can control the speed, correct? Now here, I cannot. It will be what? Very difficult, let's say. This is the first thing. The second thing, if I look to the voltage equation, simply I can't understand anything from the voltage equation. If I compare it to the DC machine, huh? If I compare the DC machine, who can give me the voltage equation of this machine?
VT
Oh,
تسوي
نوال؟ نوال؟ وين نوال؟ مش موجود صح؟ مرام؟ Can you give me the voltage equation of the DC machine separately excited? VA equal to RA IA plus LA DIA by DT plus the back EMF, correct? Which is the K phi omega, correct? Now, if I look there, it's very simple. I can understand everything. If I multiply it by the current, if I multiply this equation by the current, so simply the first term here will be what? The power input. The second one will be what? The oblique losses. The third one will be what? The change in the field energy. The last one will be what? The converted power. The converted power, correct? So this converted power will be what? I K phi omega, correct? If I divide it over omega, I will get what? K phi I. Which is the torque. Yes? See how simple is that?
Yes.
Now, we need to do the same thing for what? For the induction machine. We need to do the same thing for the induction machine. Except that, the induction machine is difficult. Three-phase. Polyphase. Yeah? It's time varying. Why time varying? The inductance matrix depends on theta. Which one? Do you remember? LSR was a function, LSR dash, let's say, was a function of theta r. So this system is time varying. Huh? And our knowledge is to deal with what? With time invariant system. Yeah? So this means that this is a not ordinary differential equation.
Yes.
By definition, the ordinary differential equation is what? The coefficients are what? Constant. Yeah? Constant. Okay. So now let's see. So someone will say, can I do transformation?
Yes.
Do you know the meaning of the transformation is what?
Converting thing from like time invariant to يعني اثبت التايم في system time invariant وادرس باقي الاشياء.
No. If you ask Patrick, he will tell you that looking to the problem from another point of view.
يعني ثيتا ار متغير لازم.
Looking to the problem from another point of view. Which means that if you are facing a problem and you are telling your problem to your friend, you say, no, it's not a problem. Why? See, it's like this and this and this. You say, yes, that's correct. So simply here, the same thing. Imagine that the frame is rotating, for example.
Okay.
The frame is rotating. Imagine that you are attaching yourself on the frame. In this case, you're seeing the frame is what? Stationary. So,
Yes.
so the transformation is what? Is changing how you are looking to the problem.
Okay.
Without changing the nature of the problem. If you are changing the nature of the problem, simply you are discussing something else. Huh? So here, coming what we call it, the reference frame theory. Quran, huh? Simply this is, will open the door to discuss what we call it, the reference frame theory. Do you see, I did change of coordinate, by the way. The first stage I was catching the pin like that. It will never right. So there's a problem. Change. So let's discuss what we call the reference frame theory. Now, to make it simple, let's assume that we have a three-phase system, stationary. So this is the ES, and this is the BS, and this is the CS. So those frames can describe any stationary cell. Stator. The stator is stationary, correct?
Yes.
So with respect to the stationary reference frame, all the quantity are alternating.
Yeah.
Yeah? The current is alternating, the voltage is alternating, and the flux is alternating, correct?
Yeah.
Yeah? Now let's assume that I'm having, wait, 3 is higher than 2. So let's assume that I'm having 2 axes. So I will transform 3 axes to 2 axes. Yeah? Someone will say, why 2, not 1? To make it easy, instead of 3, use what? 1. But it's known that for the machine, in order to rotate, you need at least 2 coils. That's why in the single-phase induction machine, it has no starting torque. Why? Because it has only 1 coil. How we can start it? Listen. مرام مرام انت اسمك كم مرام؟ مرام 1 مرام 2. So مرام So مرام. How we can start the single phase induction machine? In the machine. Dr. Sahar told you what?
بدنا نعطيه الفولتج.
كان في دكتور في كاباسيتر عشان يعمل لي
The split phase. Split phase. Which means that you are what? Artificially making another phase.
imposing another phase.
Yeah, artificially you are what? Making another phase, and simply they recommend to add a capacitor in order to to make the angle as wide as possible. Yeah, the maximum is 90. The maximum is 90. Yeah. By the way, if you just rotate it, you rotate. Yeah. That's why if you go to washing machine, مروحة صح washing machine صعب.
مروحة هذا كان.
أنا washing machine صعب شو بدي أدخل صعب. Not washing machine. فعل مروحة. If you go to the fan, just rotate it to rotate. Yeah. Without electricity, don't get them
عني
So now we agree that I need what? 2x. And the angle in between is what? So orthogonal. Orthogonal. So let's assume 1 is here and 90 degree. It will be somewhere. Somewhere near almost 90. Yeah? 90. So this one we call it the qx. And this one we call it the dx. Why we call it the qx and the dx? Simply the dx is the direct axis. Later on, it will point to the direction of the flux.
Okay.
The qx is what? The quadrature axis, 90 degrees from the dx. Yeah? Later on, it will be the torque component. So here is what? Is 90 degrees, which is the pi over 2. And I will assume that this frame is rotating by which speed? Omega. So this omega is what?
No, omega r.
This unspecified. Is there any suffix? No. So this is the arbitrary reference frame. This frame is rotating in arbitrary speed. So if omega equal to 0, it will be the stationary reference frame. If omega equal to omega r, it will be the rotor rotating reference frame. If omega equal to omega s, it will be the synchronous rotating reference frame. So instead of discussing 3 frames, I can discuss 1, which is what? The arbitrary reference frame. Then after that, I can specify which speed I need the frame to rotate with. Huh? Good? Good. Yes? Okay. So, if I'm having here any function, f, and f. And last time, we agreed that f can be anything. It can be current, it can be voltage, it can be flux linkage, correct? So the same thing here. This means that I need to find the FQ and the FD. Yeah? So, now, this will be theta. From here to here, it will be what? Theta. And this theta is equal to what? The integration of omega d tau plus theta of 0 of f if I'm having an initial angle. Yeah? Yes. Now, any transformation to be valid, it must what? Respect what? Can I use any transformation? No. For example, you can go to sleep, solve all the problem in the world, yes, and wake up and say that I'm solving everything. No, you did not. Why? You cannot put it in practice. Yeah? You solve it in your imagination. Yeah? Not in the physical frame. Remember, which frame here is the physical? The ABC. So any solution not in the physical frame is not valid. Same as Laplace. We are doing Laplace. We are solving in Laplace. In the end of the day, I need what? Laplace inverse. If I cannot find Laplace inverse, it will be useless. Yes? It's useless. Because solving the problem in S domain, we never solve the problem in the time domain. Unless you have what? The way in order to go back to the physical system. No? The physical coordinate. Here are the same. So what I need a transformation that I can go from ABC to DQ or QD, whatever, and I need to return back. Yes? Yes?
Yeah.
And I need to preserve the power. Otherwise, I'm changing the system. Okay. So here someone will say, it's very simple. If you go to ask Dr. Saleh, he will tell you that from linear algebra. It's very simple. Say that F, Q, D will equal certain matrix multiplied by F, A, B, C, S. And here I will add S because this one is S. Huh? Yeah? Okay. Someone will say, oh, if I need to find, now this seems to be simple. Why? Because I'm having the F, A, B, C, S. I multiply by certain matrix. And I'm getting what? The FQD. Now someone will say, okay, you have FQD, and I need the ABC. What you will do? K inverse. So someone will say, square the matrix, man. This will be what? 2 by 3. Yeah? And if you need to find, of course, we can do it. It's pseudo inverse to be. It will be. So someone say, square the matrix. If I need to complete the thing, I will complete it with something trivial. The trivial solution. Do you know the trivial solution? 1 is equal to 1. So someone will say, complete it with the zero sequence. VA plus VB plus VC is equal to what? 0. Yeah. So someone will say that here add 0. So this will be 3 by 3. So the last line will be what? Representing the zero sequence. It's a trivial thing. Has no relation with what? With the transformation. Only I needed to complete what? The matrix to become 3 by 3. So I can deal with the inverse
Easy.
without thinking about it. Yeah? Without asking the society to do that. So simply here it will be what? KS. Good? So someone now will say that F A B C S will equal KS inverse FQD0S. Correct? It's cheesecake. Yeah? So now let's try to find KS. Let's try to find KS. So now let's put here KS equal and let's try to find it. Now imagine I'm having a function in the direction of the A and I need to project it in the direction of the Q. What I will do? Cosine. Cosine which angle? Theta. The angle between the axes. So because I'm too old, I will use C for the cosine. And I will use S for what? For the sine. And because I'm too old, I will use C theta 1 or theta 1. Huh? This is younger now because I wrote 2 things. So we know theta. Theta 1, I will use it to be what? I will choose it to be what?
Angle between
Okay.
Angle
Theta
between-
minus theta minus 2 pi over 3. So theta 2 will be what? Theta plus 2 pi over 3. So this will save ink. We need to reduce that. عندي شو اسمك؟ حمدان.
صالح.
تفضل يا صالح. So محمد صالح. C for the cosine, S for the sine. Yes? So sine x over x equal to what?
Sin C.
Huh?
Sin CX.
No. You are thinking, man. Sine
Tan
x
x.
over x will equal to
Yes.
see? After two. Okay. So now, what the first thing here, I need to project the FAS in the direction Q, so I will multiply by cosine theta. So this will be C of theta. The yellow is not good. So let's choose the plug. So this will be the C theta. Then I need to project it I need to project B, because this one will read what? FA, the matrix here, the KS matrix, will transform FAS, FBS to FCS. Yeah?
Yeah.
So this will be the FQS, this will be the FDS, and here the 0 at the end of the day. So the first one here, projecting the A in the direction of the Q. I need to project the B in the direction of the Q. So I will project it by what? Theta 1, which is theta minus 2 pi over 3. So this will be cosine.
Cosine theta 2.
Cosine theta 1, so I don't need to think about it. It should be cosine theta 2. Now the second line will project the A, the B, the C in the direction of what? Of the D. And remember, Q and the D is what? Orthogonal. So by the magic, C will become what? S. Sine. S. Sine is 1, 2, 3. S. Right? Yes?
Yes.
So this will be what? Sine theta 1, sine theta 2. Understood? Okay. So the last line.
واحد مش انت قلت ايوه
VA plus VB plus BC equal to 0. So over 3.
اوكي
Yes, logic. The average. VA plus BB plus BC over 3. Yes? So this should be what? 1 over 3. 1 over 3. 1 over 3.
ما فهمتش ليش طلعت ما فهمت ليش طلعت ما استوعب
شيء.
الثلث هزيت راسي بس ما فهمت
ليش؟
مش ما فهمتش ليش طلعت فعليا اذا بحط اي كونستنت نفس الشيء
Now, تفرقش. Okay, now let's assume Suleiman say, okay, man, but 1, and the end of the day it will be VA plus BB plus BC, صح?
اه
And also, if I'm thinking about it as a summation of average, VA plus BB plus BC, so it will be VA plus 3 terms. If you need to take the average, it will be 1.
اه
VA plus BB plus BC over 3. It will never change anything, صح? So, yeah, let's keep it like this. Okay. Quran said, wait. If I'm having a transformation, I can scale it.
Yes.
In the end of the day, I can multiply the transformation by anything. Yeah? By 2, by 3, by 1 over 2, by blah, blah, blah. Yes? Good? Yes? Okay. Okay. Now let's see what will happen. Now someone will say, if I had the chance to do the transformation such that with no thinking about anything, I can judge about the magnitude. In general, I need useful transformation. For example, if I'm telling you that in the ABC reference frame, the magnitude is 100. What's the magnitude of the VQ, for example, in the QD reference frame? Abdullah Nishwan. Someone say, imagine I can say it's 100. Yeah? I'm preserving what? The amplitude. So this will be very useful for the transformation. Yes? Now let's assume that I'm having VA, which will equal VM cosine omega t. So VB will be what?
كوساين اوميجا تي ناقص 120 وبعدين
Yes.
زائد 120.
Yes. So now let's assume that I need to calculate the transformation at t equal to 0. Good. So I need to calculate at t equal to 0. So from here, VA is equal to what?
VM.
VM. VB will equal to what?
نص
Minus 1 over 2. It will be cosine
Minus.
1 to 0. Huh? So it will be minus 1 over 2 VM. Huh? Minus 1 over 2 VM. You know that, huh? Because if VB will equal to what? VM cosine omega t minus 2 pi over 3 at t equals 0. This will be VM cosine the 2 pi over 3. It will be what? Minus 1 over 2. And VC will equal to what?
Plus one.
نص
Plus.
The same it will be. Because you know that cosine of theta is equal to cosine of minus theta.
ماينس
Minus 1 over. Yeah, minus. So this will be the minus 1 over 2 VM. Yeah? So now I need to calculate VQ, VD, and V0 here, which will be the matrix here. Cosine theta, cosine theta 1,
Cosine theta 1.
cosine theta 1, the cosine theta 2, sine theta 1, sine theta 2, and the one sine theta 2 and the one. Here will be what? VM. Here will be what? Minus 1 over 2 VM. And here will be what? Minus 1 over 2 VM. Good? Yes? And omega or theta is equal 1. And theta was equal to the integration of omega d tau plus theta of 0. So this will be omega t plus theta of 0, correct? Yeah? So theta, let's assume that theta of 0 is equal to 0. So at t equal to 0, theta is equal to what? 0. So now the matrix will read as what? Cosine of the 0 is what?
1.
Cosine of the 2 pi, minus 2 pi over 3?
Minus 1 over
Minus 1 over 2. Minus 1 over 2. Yeah? The sign?
0.
0. The sign?
جذر 3 2
Minus. And?
1 موجب
موجب جذر 3 2.
Yes. And at the end of the day, I don't care about the last one. Huh? Let's assume it's 1 and 1 and 1. Yeah? Hey, Omar. يلا ماشي. تعرف تضرب ماتريسيز؟
أعرف أجاوبك السؤال سلبيا.
ها؟
أعرف أجاوبك السؤال سلبيا.
يلا. اضرب الماتريسيز. والله جاي. يوم اسألك واحد. Solve the equation. Multiply by 0. If you multiply by the 0, you are getting the trivial solution. حد يقدر يقول لك لا؟ شو رو كلهم يعني؟ أنا باترك باقي. اضربني يعني.
أنا أقول لك VQ.
Find VQ equal to what?
VQ equal VM
اه
plus VM over 4 plus VM over 4.
جمعهم هذول ثلاث حدود
VM plus
ثلاثة على
3
3 over 2 so 3 over 2 VM the second line
VD equal جذر 3 على 4 VM.
اسم واحد بس واحد نقدر واحد بس واحد نقدر
زيرو
بس واحد بس زيرو زيرو yeah
احتياجي.
and that's one zero huh? okay now let's return back to Abdullah Abdullah told me that imagine I can find a scaling such that the transformation will preserve the amplitude صح if I need to do that then I need to multiply by what
3 over 2.
I need to preserve the amplitude. I need to multiply by 2 over 3. Thank you. Yes. So someone will say, add here what? 2 over 3. صح? Now simply here would be 1 over 2. مش هون فوق. مش هون. هي بالترانسفورميشن ماتريكس بس مش هون. ها؟ So 2 over 3 and this will be 1 over 2, 1 over 2, 1 over 2. If this annihilation, it was 1 over 3. صح؟ So now it's 1 over 3 actually. صح؟ ولا لا؟ Now it's 1 over 3. According to the Bachmann theory, the 2 will eat the 2 and you remain with what? With the 3. صح؟ صح. So that's why sometime in the transformation matrix you can find what? Here 2 over 3. Sometimes you can find something else. Yeah? Yes? Later on we'll discuss.
الثابت نفسه لا زاوية أي time.
Yeah. If you do it, whatever the time is, you will getting the same. And this is only for balance system, by the way.
To preserve amplitude.
Yeah, to preserve the amplitude. So simply if I'm telling you that this is the signal in the ABC, give me the BQ, it will be what? VM and VD will be what? 0 in 2 conditions. The first one is what? The system is balanced, and the second one?
VM 0.
Okay. Theta 0 not equal
Ah,
to
yes. Theta 0 not equal to 0. If theta 0 is if theta 0 not equal to 0, it's not correct. Correct? Good? Good. Okay. So we agreed why until here. We agreed that why I need this transformation matrix and why I'm introducing this fact. So someone will say now you have chaos, give me chaos inverse. Why? Because if you are solving your problem in the Q and the D reference frame, in the end of the day the inverter cannot understand the Q and the D. The machine cannot understand the Q and the D. The machine understands the ABC. Yeah? Count, you can say 3 terminals. A, the B, the C. The 3 phases called line 1, line 2, line 3, called SRST, called whatever you want. XYZ, call it whatever you want. It's the machine variable, the ABC. Huh? So now, I need to find what?
KN.
Chaos inverse. And chaos inverse for 3 by 3 matrix is not a big problem actually.
Determinant.
I don't need it. I have it. And this is very simple by the way. It's cosine theta, sine theta, and here is 1. And here will be cosine theta 1, cosine theta 2, and the 1, and this will be it. Sine 1.
Cosine
This
theta
will be
2
the
sine
sine theta 1, this will be the cosine theta 2, this will be the sine theta 2, 1 and 1. It's very simple to remember. It's actually the transpose. Almost the transpose. Almost. Not the transpose. Fine.
concept.
That's why I call it almost the transpose.
We factor one.
It's not the transpose. But simply it's very simple. Because the first 2 column is taken directly as the transpose of the first 2 lines and 1 to complete the matrix. هيك أحسن صح. But simply wait. Omar said something very straightforward. What about if I can find a transformation matrix such that the transpose is equal to the inverse? There is the screw matrix.
Okay.
The screw matrix is what? The A transpose is equal to A inverse.
Okay.
صح? So A by A transpose is equal to what?
Identity.
Identity. صح? So we can do that. Yeah. Good. But before doing that, let's calculate the power. So the power in the ABC will equal to what?
ABC. VA.
احكي خافش.
VAIA.
أيوة.
VD زائد VDIA.
It's VAIA plus
VB.
VBIB plus VCIC. Yeah. Or in matrix form it will be what? VABC transpose IABC. So yeah. So this will be the VAIA plus the VB, the IB plus the VCIC, or it will equal the VABC. Of course, I'm discussing stationary. Multiply by IABCS.
As matrices.
Now, someone will say, I need to find the power in what? In the QD reference frame. So Quran, كيف راح يكون الباور there? The power there. I need to find the power in the QD reference frame. Can you give me a relation for the power?
نحولها عن طريق الماتريكس.
يلا حول يا شيخ.
نستخدم
يلا تعال حول. So simply remember, if I'm having the FABCS, if I multiply it by KS, I will get what? The FQD0S. Yeah? And if I'm having the FQD0S, if I multiply it by KS inverse, I will get what? The F, the A, the B, the C, and the S, and the F can be anything. So, how? So this will equal to what? VABCS will equal to what? From here. So, over bracket, it will be KS inverse VAB, not V. It's VQ, huh? VQD0S, or what? Multiply by, which is KS inverse IQD0S. صح? Now, this will read as what? مرام. التلفون وين؟ مهم كثير كان صح. طيب فكي لي يعني. شو بصير؟ بنقلبه. بعد ما نقلبه نضرب واحد بعدين نقسم مع واحد. Flip it, huh? So VQD0S transpose KS inverse transpose, صح؟ صح. So this will be what? يعطيني اياها. يلا. VQD0S transpose KS inverse transpose KS inverse IQ D0S. Yeah? So I need to evaluate this one, Chris.
حكينا هاي
هذا المفروض
هاي الايدنتيتي اللي هي
هذا عمر حكى. If you can change you can change the factor such that the
إذا كان-
inverse is equal to the transpose, but our matrix is not the transpose.
Okay.
شو قلت له slightly transpose. No, it's not the transpose. So similarly, someone will say, yes, from here I can scale the factor. So someone can think about scaling the factor such that the transpose is equal to the inverse. So in the end of the day now, the power in the ABC will equal the power in what? In DQ. So, which means that VQIQ plus VDID will equal
حتى هون
that.
يعني
No.
سكيل الباور
No. No. That's why I need to evaluate this one. بس مش لو كان حكى هسه خلاص ما بدي شيء.
ليش هذا؟
ني اقول انت مين بقول ني يعني كلا
جدا.
لا، ما. طيب. So now let's try to evaluate so let's try to evaluate this one, which is the KS inverse transpose multiplied by KS inverse. Do we have the KS inverse?
Yes.
So شو اسمك يا اخي واحد؟ محمد ايش؟ حنقول شنو؟
محمد صالح.
محمد الصالح. في عندنا الدكتور محمد الصالح الكيماوي. ما شاء الله عليه. اوكي. يا محمد give me the first one. KS inverse transpose.
Cosine theta 1. Sine theta 1. Sine theta cosine.
And
Cosine theta 2.
لا مش كي. دقيقة بعد. الكي والفاكتور.
كيف
Now I'm evaluating to tell you that this transformation, the 2/3 that I introduce, is not power invariant. The meaning, the power are the same. The power in the ABC is the same as the power in the QD. But the meaning of the power invariant and the power is not invariant is what? That I can say VAIA plus VBIB plus VCIC is equal VQIQ plus VDID. In this case, the power is what? Preserved. Yeah? But here you will see it's not. There is a factor. There is a factor. And this factor due to what? The selection of our factor. So I need to multiply it by what? By that one, which is the cosine theta, sine theta, the one. And
Cosine theta 1.
احكوا لي قبل ربع ساعة. Cosine theta 1, sine theta 1 and the 1. Cosine theta 2, sine theta 2 and the 1. يا محمد يا صالح. تعرف تضرب؟ تحكي ليش صف بعمود؟ بخدم. The first one. يعطيني.
Sine theta تربيع.
كوساين ثيتا تربيع.
كوساين تربيع.
Cosine theta 1.
So let's make room. Let's make room. There's a room. يلا اعطيني.
Cosine theta تربيع.
كوساين ثيتا سكوير اللي هي all the cosine square. بلس.
Cosine theta 1. وزائد cosine theta 2 تربيع.
يا كم؟
دقيقة وين الصفحة؟
Sine theta 1 تربيع. Sine theta تربيع.
انت بالصف ولا بالعمود ماشي؟ ما بتفرقش معك.
Cosine theta
ساين
sine theta.
ثيتا ساين ثيتا.
Cosine theta
Sine.
1 sine theta 1. Cosine
شو رايك اكتبها تحت؟ اساس ما اظنش اروح يمين شمال. So this will equal the first term is the cosine theta square plus the cosine theta 1 square plus the cosine theta 2 square. The second term is the cosine theta sine theta plus cosine theta 1 sine theta 1 plus cosine theta 2 sine theta 2. The last term? That's so, which is the cosine, cosine, cosine. Yeah? This is cosine theta plus cosine theta 1 plus cosine theta 2. Correct? The second term. So similar to this one, huh?
Yeah.
Right? So this one here. Yes?
Yes.
So this term, I will put one. Huh? This term. This term. This will be square. So this will be the sine theta squared plus sine theta 1 squared plus sine theta 2 squared. This one will be the sine. Correct? Sine theta plus cosine sine theta 1 plus sine theta 2. This one, the cosine, this one, the sine, this one is what? 1. So simply this one I will call it 2. So this will be what? 2. The 2. And this one will be the 3. So this will be what? 3. So?
ليش واحد مش ثلاث؟
Wait.
ثلاثة.
This one?
Yeah, 3.
3. Oh, في 1 over 3. That was here, so it's coming back. This 1 plus 1 plus 1 is what? Is it 3? Right? It's 1. It's 3. Nescafe. 3 and 1. Yeah? Okay. Now let's see. So let's return back to the first page. I have page. Did you see the first one?
Yeah.
And the second one here? This one, huh? Yeah, I'm pointing to this. Eric? You see this one? لا this one.
مش هيك بنقدر نحكي عنها زي
This one. Do you see this one? And this one? Those equal to what? And the sine?
3 over.
صح?
Okay.
And sine, cosine, sine, cosine, sine, cosine?
0.
And the cosine plus the cosine plus the cosine?
0.
And the sine plus the sine plus the sine?
0.
No. Next to. Oh. So this will be what?
3 over 2.
This will be what?
0.
This will be what?
0.
This will be what?
3 over 2.
3 over 2.
0.
صح؟ Now مظبوط؟
صح.
صح 3 over 2.
صح ولا لا؟
صح.
So this will equal to what? 3
3 over 2.
over 2, 0 and the 0, 0, 3 over 2, the 0, the 0, the 0, and
3.
ها؟ قريب لللاين. يميل والقلب يميل. طيب. So now, if I do the math, if I need to calculate the power in the QD0S is equal to what? مين بفرط لي إياها؟
P
بصير 3 over 2 VQ IQ plus
3
3
over 2.
over 2 VD plus 3 V0 I0. So someone will say, if you are taking 3 over 2 as a common factor, why? To say that VQ IQ plus VD ID plus
2
V0 I0. So now the power is not preserved. There's a scaling, which is 3 over 2. Why? Because I use the
2 over 2.
yeah, in the transformation. صح? So this is will be left for you to design the scaling factor in order to preserve the power, which means that I need to find now KS modified KS, huh? A modified KS. KS is a modified which contains 2 factors, alpha. Here, cosine theta you cannot touch. Cosine theta 1 you cannot touch. Cosine theta 2 you cannot touch. Sine theta you cannot touch. Sine theta 1 you cannot touch. Sine theta 2 you cannot touch. And here let's assume it is M, and M. Why? According to Suleiman, what anything? Yeah? So I need you to find this homework for you. Huh? Find alpha and M such that the transformation is power invariant. Power invariant. Such that the transformation
power invariant يعني دكتور power preserved.
yeah, such that the power in the A, B, C is equal VQ, IQ plus VD, ID. صح?
Plus V0 I0.
Yeah, but at the end of the day, V0 I0 to be equal 0.
Yeah.
Yeah? Such that the power is preserved.
enter around 2
طب دكتور
فلفل.
بسويها دكتور مثلا هاي المعادلة نفسها بما ان في 0 اي 0 بسويها بضربها ب 2 على 3 خلص.
وهي بعملها فلفل اللي تحت.
المعادلة اللي بالاحمر هاي مش في 0 اي 0 0 فبشطبها من المعادلة بضرب ب 2 على 3.
This is a pattern.
بخلي الام واحدة في الاس.
When you do differentiation, if you need to do differentiation, I'm giving you a complex function, and I need you to evaluate the differentiation at certain value. Suleiman said that put the value in the function, it will become constant. Differentiate it, it becomes 0.
initial condition.
The 2 over 3 is coming from here.
نضربه.
هو بده يرجع رجوع يطلع بدل ما ينزل. هو بده يرجع
يعني
ماتريكس.
نضرب 2 على 3 نضرب باللي قبل 2 على 3 16.
So simply here, you need to say that I need to say Ks is equal, inverse is equal to Ks transpose. If I do that, then if I return back here, this what I evaluate, correct? Yes? This actually, if Ks transpose is equal, Ks inverse, this will equal to what? Identity. If this equal to the identity, then in the end of the day, the power in the Q will be what? VQIQ plus VDID plus V0I0. صح؟
بس احنا هون مش هيك.
شو هي؟
هون ما عندنا هذا الكونديشن.
احنا بدنا اياه نعمل هيك نضربها فاهم
شو اسمه؟ علاء انت اخذت علامة قبل. Keep it. Don't get it. He keep the point. Right? Actually, this is the problem that we need to solve. Yeah? Yeah?
Find alpha and M such that
Yeah, we need to find alpha and m such that Ks transpose is equal to Ks inverse. This is the key to solve it. Yeah? So multiplying by 2 over 3 will not solve it. Yeah? Okay. Until here, we are good to go. So. So now, after knowing the transformation, let's implement it. Let's what? Implement it. So let's try to do the transformation for stationary circuit in the ABC reference frame. Okay. Which was so I will do the stationary circuit transformed to the QD reference frame. Good. So if you recall the voltage in the VABCS, it was what? We wrote it in the first one. RS, the IABCS plus d by dt of lambda ABCS. Let's do transformation. Yeah. The first one, what I should do? I need to find it in terms of what? Q and the D. So the first thing, what I should do?
I will transform the VABC.
If I need to transform any variable from ABC to the DQ, what I should multiply by?
By KS.
KS inverse, huh?
المفروض KS.
Now see, FQD0S is equal KS FABCS. So the first thing here I will do what? I'll multiply by KS. Multiplied by KS automatically. The first one is the V, the Q, the D, the 0, the S will equal KS. R, here I need to use what? FABCS is equal KS inverse
ID.
the F, the Q, the D, the 0S. So here what I should put?
On K inverse. K inverse I Q D 0.
KS inverse the I
Q D 0.
Q D 0S plus here I'm having KS due to what? I'm multiplying. Then I'm having D by dt and here what I should put? KS what?
KS
Inverse
lambda Q D 0.
lambda Q D 0S. Straightforward.
Yeah.
Direct path.
Okay.
The shortest line. Good? Good. Now RS, do you remember RS? RS this one. RS is equal to what? It's diagonal matrix. Yeah? RS is matrix. Represent what? The pair phase resistance. صح? So on the diagonal I will find what? RS, RS, RS. And the off diagonal is what? So it's actually RS multiplied by the identity matrix.
Yeah.
So this can be written as RS as a value
Okay.
multiplied by the identity matrix.
Yeah.
Is it correct? This is the identity matrix?
Yeah.
صح. So you know that this means that you multiply KS by KS inverse. So now you are getting VQD0S will equal RS IQD0S. And this is, by the way, logical. Why? Because R in general is representing of what? In the circuit, we use it to represent what? Work, dissipated energy. So this actually ohmic losses. So imagine that the ohmic losses is changing from the ABC to the QD.
مشكلة.
It will be a problem. You are changing the problem. Yes? It's logical to have RS the same. And this is only for symmetrical. If RS not symmetrical, I cannot do this one. Huh?
Okay.
And we are discussing symmetrical. If you are interested in unsymmetrical, later on. Good? Okay. So now, plus, I need to evaluate this one, yeah, this one. Change the way of looking. بدل ما تقول زي فرطيها I need to نفرطها.
KS time dependent مش لازم.
KS is not time dependent. ثيتا شو بتسوي؟
بس
سؤال استنكاري أم سؤال استفهامي؟
لا سؤال استفهامي.
KS is time varying because until now I'm not specifying the reference frame. It's arbitrary, it rotates with any speed. So it depends on theta. Yes?
negative.
Yeah, so it's time varying. So if I need to differentiate here, I'm having two functions time varying, multiply by each other, and I need to differentiate. So I will use the chain rule. Chain rule. That's market. That's what? That's lesson.
Yes.
It's the most famous method maybe in the era. لا في ماركت بس نو ولا ماركت جسر
ذات الصوالي مش السلس.
ذات الصواني.
قريب. If you count the letters it's be the same. And this nice. So chain rule يلا اعطيني الchain. KS d by dt of KS inverse lambda q d0s plus KS inverse d by dt of lambda q d0s. Now this one we know it's what? It's this? One كبيرة. The identity. It's identity matrix. Huh? So until now, in order to finish this lecture, I need to evaluate this one. So to evaluate this one, I need to do the first thing is differentiation. So who can differentiate d by dt of KS? Where is KS? That's right. Yeah. I need it. I need to evaluate this one. So here I will write the KS, which was the cosine theta.
Cosine theta.
Cosine theta 1, 1, huh? Cosine theta 1 and 1 here. Sine theta. Sine theta 1 and 1 here.
لسه ما اشتغلت.
هاي كي مش هيك دكتور.
كوساين So KS is cosine theta 1 and cosine theta 2, so 1 sine theta 2 and the 1, the 1 and the 1. Yeah? Good?
Okay.
This KS in this. There's a 2 over 3.
High KS.
High KS.
You need the KS.
كنت بتكسر
KS inverse.
عشان اعمل differentiation.
1 over 3 ولا 1 over 2؟
هدول الارقام الزامنه والريزيرف والبوند.
Yes. Just a minute. Suleiman, forget anything about modifying the transformation matrix. Now, my transformation matrix is what? 2 over 3 cosine theta 1, cosine theta 2. Sine theta 1, sine theta 2, 1 over 3, 1 over 3, 1 over 3.
Okay.
I need to proceed.
Okay.
If I'm not fixing the transformation, I can't do anything.
Okay.
But the KS inverse.
It's the KS inverse. So 1 over 3 ولا 1 over 2؟ 1 over 3 ولا 1 over 2؟
1 over 2 بتصير 1 over 2.
1 over 2. 1 over 2.
It's 1 over 2, yeah, because 2 over 3. So
over
at the end of the day, it's 1 over 2. I fixed it, I think, huh?
Yes.
1 over 2.
So this one is the cosine inverse, which is the KS inverse, which is the cosine. Cosine theta, cosine theta 1,
Cosine theta.
Sine cosine theta 2, the sine theta, sine theta 1, sine theta 2, and here 1. Huh? Now I need to what? To differentiate. So I will d by dt here. So I will use d by dt here. Omar, differentiate. Yeah.
You minus sine theta.
Minus sine theta.
First row.
The first one.
The first row minus sine theta.
Minus sine theta.
Cosine theta and 0.
Okay.
Minus sine theta 1. Cosine theta 1. 0. Minus sine theta 2. Cosine theta 2 and 0.
أكيد. أكيد.
Then multiply by theta.
Multiply by?
By theta inside the cosine.
This is the problem.
إذا في شيء multiply by cosine theta داخل الكوساين يعني في شيء 2 3 رقم.
ثم لو كان في رقم هنا هيساعد الآن الرقم.
عكس موجود
The augmented function كيف تعمل differentiation داخل؟ هسا if you have f of x d by dt كيف تعملوها؟
f of x
برايم اكس بلس سي.
شو هي؟
بلس سي بلس سي
بس ايش؟
سي
تعمل انتجريشن take the limit
اف برايم limit.
كان في لي صاحب اي problem you face take the limit partial limits by partial x dot صح here what you did you say that partial by partial theta and where's theta dot which is omega so here I need what I need omega صح omega is what d theta by dt someone say what about d theta 1 في نفس because there's a constant huh? that's why I told you I don't care about the constant so okay now let's multiply it if I can multiply it then my life will be easy so let's multiply it I'm gonna have let's multiply it and I will multiply it let's multiply it if I multiply it simply I will say this will be omega then this will be the 0, the 1, the 0, the minus 1, the 0, the 0, the 0, the 0, the 0. صح؟ مظبوط؟ Yes?
Okay.
Okay. So now, if we do that, then now who can help me to write the voltage equation in the QD0 frame? You will say that it is RS IQD0S plus d by dt of lambda QD0S plus omega multiplied by this one 0 1 or 0 minus 1 0 0 0 0 and 0 multiplied by what? By lambda QS lambda DS and lambda 0S صح؟ مظبوط؟ صح؟ To finish the lecture, who can give me VQS equal to what? Who can give me VDS equal to what? Who can give me V0S? فوطيها يعني The first one RS IQS plus d by dt of lambda QS plus omega lambda ds.
Yeah.
The second one RS IDS plus d by dt of lambda ds minus omega lambda QS. The last one RS I0S plus d by dt. Lambda 0s. Look to this equation and compare it with the voltage equation of the split excited DC machine. Almost the same.
Yeah.
Right?
Yes.
Huh? Yeah, almost the same. So simply here, I know that the first part is the drop voltage across the resistance.
Yeah.
The second part is the voltage induced due to static coupling, like transformer. The third part is what? Is the voltage induced due to rotation. صح? صح? Very straightforward. Yeah, now we can understand each term, and I will stop here. Later on, I will start from this point. ها؟ يعطيك العافية. عندكم سؤال؟ لا. يعطيك العافية.
شو ما
شو هو؟